Let's do a quick Chapter 8 review. First off, this is the hypotenuse of a right triangle. It's across from the 90 degrees, that box. Trigonometry, the measure of triangles, involves ratios, such as sine, cosine, and tangent. These ratios tell you how long one side length is compared to another based on an angle. Out of these three items, you'll be given at least two in a problem, and you'll have to find the other one. If you put sine 30 into your calculator, you get 0.5. Another version of 1/2 is 3 over 6, because what the sine of 30 actually means is if you have an angle over here that's 30 degrees, and this side is 3, this side has to be 6. 3 over 6, 1/2. And if you have an angle down here of 45 degrees, and we know that tangent of 45 is 1, so says our calculator, if this side is 4, this side has to be 4, because there's a ratio of 1 to 1. Or if we have an angle here of 60 degrees, our ratio between these two sides has to be 1 to 2, so it's 4 to 8 here. Now most of our problems end up using lots of decimals, but that's what these ratios represent. Sohcahtoa. It's a memory trick. The sine of an angle is equal to the opposite leg over the hypotenuse. This OH that's associated with the S tells you the ratio for sine. For cosine, given an angle, we look at the adjacent leg over the hypotenuse. So this AH is associated with cosine. And finally, given an angle, we look at the opposite leg over the adjacent leg. That's where the OA is associated with tangent. 3 quick basic ratio problems. This problem is about tangent, and it's focusing on angle A. Start here, opposite over adjacent, 30 over 16, done. Sometimes we write this as 1.875. That's the ratio, that this side length is 1.875 times bigger than this side length. Next one, cosine, adjacent over hypotenuse. Start here, 12 is adjacent, 12 over the hypotenuse, 15. Could also write it as 0.8. Sine of Z, opposite, 12, hypotenuse, 20. The ratio, 0.6. Next, we're going to solve for some unknowns. So first, the angle here is x. Relative to x, 6 is an opposite leg, and 20 is the hypotenuse. That means we're going to use sine. We set up a ratio that the sine of x is equal to 6 over 20. So what we're trying to figure out is what angle could possibly fit in that would give us this result. Find the answer in one step with your calculator. Inverse sine of 6 over 20. Turns out to be 17.5. Don't believe me? Try to find sine of 17.5. Wouldn't you know it? It's 0.3, the same thing as 6 over 20. Here's a cosine one. We know the adjacent and the hypotenuse side lengths, 10 and 15. We can find this by taking the cosine inverse of 10 over 15. Straight to the answer. Here's a tangent one. The ratio for tangent is opposite over adjacent. We plug that into the inverse tangent, we get right to our angle. 35 degrees will give us this ratio of 0.7. In this one, the sine of 60 is equal to the opposite over the hypotenuse, or 10 over x. Since we see that x is here on the bottom, we know we're going to end up dividing. So we'll take 10 divided by sine 60. This gives us about 11.5. Sine 60's ratio is 0.866. 10 is 0.866 times as big as 11.5. Cosine of 30 in this diagram is equal to the adjacent leg divided by the hypotenuse, or x over 15. Since x is on top, we know we're just going to be multiplying. 15 times cos 30 is 13. That's how long this side length is. Last one is tangent. Given this angle 25, the ratio is opposite over adjacent. We fit that in as x over 12, and this becomes 12 times tangent 25, about 5.6, based on this angle. Those previous 9 examples will cover 90% of the test. Last couple, word problems like this. Given a 20-foot ladder that's 5 feet away from the house, when they talk about the angle of elevation, that means the angle at the bottom, this one down here. And you figure out that we're looking at cosine, and you take the inverse cosine of 5 over 20. If they had asked about the angle of depression, that would have been the one at the top. This one here is 75.5 degrees. Here's another scenario. A man on top of a 50-foot tall building, shouting to a guy 75 feet away from that building. If I asked you which angle was the angle of depression, it's the one on top. So we then take the tangent inverse of the opposite over the adjacent, and we get 56.3 degrees.